So see, now what is the difference in between the counting semaphore and the binary semaphore? So semaphore, it is nothing but the variable. For example, the variable is, so in the counting semaphore, the value of the semaphore variable, it is from 0 to infinity, that is any non-negative integer value. Whereas if we are using the binary semaphore for to achieve the process synchronization, then that variable, it will take only two values, that is either 0 or 1. Okay, that's why it is called as binary semaphore, because it takes only two values. So here in the semaphore, two types of operations are there: wait operation and the signal operation. So we have studied these two operations in the counting semaphore also. So now what is the wait operation? So this wait operation, it will work only when the value of the semaphore is 1. What is the meaning of this? That is, the process, it can enter into the critical section only when value of the semaphore is equal to 1. And the process will wait for the critical section if value of the semaphore, it is equal to 0. If value of the semaphore variable, it is equal to 0, its meaning is that one of the processes there in the critical section which is executing the shared resource, so other process will enter into the suspended state. So in the binary semaphore, only by using these two values, the mutual exclusion is achieved. So it is easy to implement the binary semaphore than the counting semaphore, because only two values are used in the binary semaphore. So see, this is the code which is written for the binary semaphore. So on the left hand side, we are representing the wait function. On the right hand side, we are representing the signal function. So let us consider that number of processes are there which are present in the ready, and all the processes want to execute the critical section. So that process, it can enter into the critical section only when it will execute the entry code which is written for the binary semaphore. For example, suppose let us consider process P1 is there. If process P1 want to execute that shared resource, then at first it will execute the entry code, then only it will enter into the critical section. And once its execution will be completed, then for coming out from the critical section, it has to execute the signal function. Then only process it can come out from the critical section. Okay, so wait function or this wait code, it is called as entry code, which is written for the binary semaphore, and signal, it is called as exit code, which is written for the binary semaphore. So this wait, it is also called as P operation, whereas signal, it is also called as V operation. So wait, it is also called as sleep operation, whereas signal, it is called as wake up operation. So these are the synonyms for this word, wait and signal. Wait code is there, which is also called as entry code, and signal function is there, which is called as exit code. The process can enter into the critical section only when value of the semaphore is equal to 1. And when the process will enter into the critical section, it will change the value of the semaphore variable, which is equal to 0. It will change that value from 1 to 0. So if other process will try to enter into the critical section, then it will check if the value of the semaphore variable is equal to 1. So it is equal to 0, because one of the processes there which is executing the critical section. So that process will enter into the suspended list. And when the first process which is executing the critical section, if it will finish its job, then before coming out from the critical section, it has to execute the exit code which is written for this binary semaphore, and it will execute the exit code, and that time it will check whether any process is there in the suspended list. If the process is present in the suspended list, then it will select that process from that suspended queue, and then that second process, it will execute the entry code which is written for this semaphore. For this, we will take a simple example. Let us consider two processes are there, P1 and P2. These two processes are there which are present in the ready queue. So now process P1, it want to execute the shared resource, or it want to enter into the critical section. So for entering into the critical section, this process P1, it has to execute the entry code which is written for the binary semaphore. So let us consider process P1 is arrived in the ready queue, and consider that as this semaphore, binary semaphore, it will take only two values, that is 0 and 1, because this is the binary semaphore. So let us consider the initial value. There is no process in the critical section. Your critical section is empty. No process is executing the shared resource. So that time the value of the semaphore variable is equal to 1. So now process P1, it want to enter into the critical section. So process P1, it will execute this entry code. So this process P1, it will call this wait function by passing this value of the semaphore variable s, which is equal to 1. So it will call the wait function by passing this value 1. So that 1, it will get collected into the semaphore variable. So now value of the semaphore variable is equal to 1. So now it will execute the next instruction which is written inside the wait function. So here it will check if the value of the semaphore variable is equal to 1, because process can enter if it is equal to 1 only. So it will check if the value of the semaphore variable is equal to 1. So this condition is true, because initially we are assuming that no processes are there which are present in the critical section. So because of that your critical region is free. So this condition is true. So what your process will do now? Now it will change the value of the semaphore variable from 1 to 0. So this value is initially 1, so it will change that value to 0. This s dot value, this is the local variable, so it will change value of that variable to 0, and after that, that process, it will enter into the critical section. So let us consider that process P1, it enters into the critical section. Okay. Now let us consider that. So here value of the means when the process P1 it enters into the critical section, that time value of the semaphore variable is equal to 0. Now let us consider that another process P2 it arrives, and now this process P2 it also want to execute the critical section. So for entering into the critical section, this process P2 has to execute the entry code which is written for this binary semaphore. So now process P2 it will execute this wait function or entry code. So now it will call this wait function by passing the value of the semaphore variable s equal to 0. So it will call this wait function, and that value 0, it will get collected into the variable s. So here value of the semaphore variable s, it is equal to 0 now. Now here it will check. So whether the value of the semaphore variable is equal to 1. But now currently process P1 is executing the critical section, and it had changed the value of the semaphore variable equal to 0. So because of that, the value of the semaphore variable, it is not equal to 1, because it is equal to 0. Because process P1, it had changed that value. It is equal to 0. So because of this, that process P2, it cannot enter into the critical section. It cannot access that shared resource. So what it will do, it will execute the statements which are written after the else part. So process P2, it will execute this statement. So here it will, that process is blocked. Your binary semaphore, it will block that process, and after blocking that process it is entered into the suspended list. So that process, it is placed into the suspended list, and after that it will go from ready state into the sleep state. Means it will goes into the sleep state. So process P2 it is suspended, and currently process P1 is active because it is present in the run state. Only process P1 is present in the critical section, and process P2 it is present in the suspended list. Now let us consider that process P1 it has completed its job. Currently your process P1 it is present in the critical section, and it has completed its job. And this process P1 it want to come out from the critical section. So before coming out from the critical section, this process P1 it has to execute this exit code, which is written by using the signal function. So your process P1 it will execute the exit code or the signal function. So see now what is this exit code. So process P1 it will execute the statement which is written after the signal function. So here it will check if the suspend list is empty. See, it will check if any process is present in the suspend list which is waiting for the critical section. So currently your suspended list or block list, it is not empty, because your process P2 it is waiting for the critical section, because that process is placed into the suspended state or into the block state. So here it will check that if suspend list is not empty, it is not empty. See, if it is empty, then it will execute the statement which is written after the if. But now the suspended list is not empty, means this condition is not true. So it will execute the statement which is written after the else part. ये पार्ट एग्जीक्यूट होगा, बिकॉज ये कंडीशन ट्रू नहीं है आपकी, सस्पेंडेड लिस्ट आपका एम्प्टी नहीं है. So here if suspended list is not empty, it will execute the else part which is written for this code. So what is the else part? So in the else part it is written that select the process P2 from the suspended list, because it will get one process which is waiting for the critical section. So it will select the process P2 from the suspended list, and it will perform the wake up operation. So it will perform the wake up operation and that process it is added into the ready queue. Okay, suspended से वो move होगा और फिर से ready state में जाएगा and after entering into the ready state again it will attempt to access the critical section. Okay, so that process it is removed from the suspended list, it is added into the ready queue and after that it is performing the wake up operation and after that again it is changing the value of the semaphore variable. See, it is changing the value of the semaphore variable because when process P1 was executing, that time the value of the semaphore it was changed from 1 to 0. So currently the value of the semaphore variable is 0. So because of that, no other process can enter into the critical section. So as the job of the process P1 is completed, it is changing the value of the semaphore variable from 0 to 1. So now it is setting the value of the semaphore variable equal to 1 and that process it will come out from the critical section. Okay. Have you understood? So you write down this one, left side details, and here you write down that this is the signal. Process P1 it is performing, it is executing the signal function, or which is also called as wake up function, B function, or up function. You should know all these synonyms. Okay, so now process P1 will come out from the critical section. So your critical section is empty and value of the semaphore variable it is equal to 1. So now process P2 as it is present in the ready queue, it will try to access the critical section. Okay, initially it was present in the suspended list. So because of that it was not possible for the process P2 to access the critical section. But now that process P2 it is present in the ready state. Ready state का मतलब होता है कि that process is ready to execute and it is waiting for the critical section. So now process P2 it can attempt to enter into the critical section. So now process P2 it want to enter into the critical section. So your process P2 it has to execute the entry code which is written for the binary semaphore. Same thing we are continuing now. So process P2 it will execute the entry code. So process P2 it will call the semaphore wait function by passing the value of the semaphore variable which is equal to 1 because ये value process P1 ने इसको 0 से 1 किया. So process P2 it will pass this new value of the semaphore variable to this wait function. So it will get collected into the variable s and then it will check that if the value of the semaphore variable is equal to 1. So now this condition is true. So before entering into the critical section, it will change this value from 1 to 0 so that no other process can enter into the critical section. Because here we are achieving the mutual exclusion and process synchronization. So it will change the value of the semaphore variable to 0 and it will enter into the critical section. So now in the critical section, process P2 is there. Now your critical section is also free and your suspended list is also free. ठीक है, क्रिटिकल सेक्शन में आपका कोई भी प्रोसेस नहीं है. So now process P2. Now let us consider that process P2 it has finished its job. So before coming out from the critical section, that process P2 it has to execute the exit code. ये कंपलसरी है. प्रोसेस को क्रिटिकल सेक्शन में एंटर करना है तो उसको एंट्री कोड एग्जीक्यूट करना है, उसको उससे बाहर जाना है, देन आल्सो इट हैज टू एग्जीक्यूट द एग्जिट कोड. It cannot directly come out from the critical section without executing the exit code. So now process P2 it has finished its job. So process P2 it will execute this signal function. A function that will execute, that is exit code. So process P2 now it will execute the exit code. So now it will execute the statement which is written after the signal function. So here it will check if the suspend list is empty. So see, in the earlier case when the process P1 it had completed its job, that time your suspended list it was not empty because that time process P2 was there in the suspended list. But now this time when the process P2 is executing the exit code, no process is present in the suspend list. So your suspended list is empty now. So as your suspended list is empty, so it will execute the statement which is written before the else part. That is the statements which are written after the if. So what your process will do now? It will change the value of the semaphore variable from 0 to 1. क्योंकि process P2 ने तो उसका value 0 कर दिया था. अभी उसको उसका value फिर से 1 करना है so that other process can enter into the critical section. और यहाँ पे suspended list में तो कोई भी process नहीं है. So there is no need to select any process from the suspended list. So simply it will change the value of the semaphore variable to 1 and it will come out from the critical section. So now at this stage, your critical section is also empty and your suspended list is also empty.